Hey, in this video, we're going to do some practice problems from 211. We'll start with some implicit differentiation problems. So we have y squared plus 7x cubed minus 3x equals 8. And we want to find dy dx. And then that's A. And then B, we want to find the value at 1 comma 2. This is really two separate problems here, or two parts, I should say. Separate parts, part A and part B. So to find dy dx, we're going to take the derivative of everything. Now, the derivative of y squared, that's going to be 2y times y prime. And again, that's the 2y is your outer derivative, and the y prime is your inner derivative, because again, y is a function of x. The derivative of 7x squared, that's just 21, 7x cubed is just 21x squared. That's a straight derivative. The derivative of 3x is just 3, so it's minus 3. And the derivative of x, 8, is 0, because that's the derivative of a constant. Now I just want to solve for, now the rest, that was all the calculus. By the way, you'll notice that in calculus problems, there's usually like one step of calculus and there's a jillion steps of and this is, from this point on, it's all just algebra. So we're going to bring the 3 over to the other side, and we're going to bring the 21x squared over to the other side. I get 2y, y prime, equals 3 minus 21x squared. But I want y prime inside. That's all I want is y prime, so I'm going to divide both sides by 2y. And there's my answer. There's my answer right there. Y prime equals 3 minus 21x squared over 2y. And that's part A. Now for B, I'm just going to say I want y prime of 1 comma 2. And we're going to just plug in y prime of 1 comma 2 equals 3 minus 21 times 1 over 2 times 2. And that comes out to be 18, negative 18 over 4. That comes out to be, let's say, negative 18 over 4, which reduces to negative 9 over 2. Now I'm going to add a part C. And what I'm going to do, I want to point out, you see, why do I have to say 1 comma 2? What do we need to mention the 2 for? Well, obviously I want to plug in the 2, but also, you see, just because x is 1 doesn't mean y is going to be 2. You see, that's what we're saying here. Just because x is 1 does not mean that y is going to be 2. It's possible that x could be 1 and y could be a different number. For example, let's just check it out. Suppose I put in x equals 1 into my original equation. So that gives me y squared plus 7 minus 3 equals 8, which now becomes y squared equals 4. Well, y squared equals 4, so y could equal plus or minus 2. But so it's conceivable I could find y prime of 1 comma negative 2. And when I do that, I'm going to plug negative 2. Well, this is just going to equal 3 minus 21 times 1 over 2 times negative 2. And that's going to give me what's going to be basically the same answer as before, only now it's going to be a positive number. It's going to be positive 9 over 2. And that's going to be my y prime 1 comma negative 2. Now, I'd like to, let's see if I can get something really special now for you all. So what I want to do is I want to go to Desmos. I want to share my screen with you. Let me make sure let me make sure that I just got to get the okay, so now you should be able to see this now. So I'm going to plug in the equation y squared plus 7x cubed minus 3x equals 8. And whoa, that's kind of awesome. And let's see when x is 1. Here's when x is, oops, x is 1. Let's trying to get that right there. X, oh. So I see when x is 1. I don't know why it's not letting me. Let's just do it this way. Let's do the point 1, comma 2. That's the point right there. And let's look at 1, comma negative 2. That's that point right there. It's just right. So you see 1.2, 1 point negative 2, they're both on the graph. And so all I know is that the slope of the tangent here would be negative 9/2. Now let's see if we have to do a little more algebra here. I'm gonna have to go back to my back to the drawing board over here. Hold on. I'd like to find the equation of that line so I can plug it into Desmos. Okay, so for 1, comma 2, and the slope of negative 9/2, we have y minus 2 equals negative 9/2 times x minus 1. And for this point, 1, comma negative 2, and m equals positive 9/2, so the equation would be y plus 2 equals 9/2 times x minus 1. I'm going to type these two guys into Desmos, and if we did this right, they should be perfect tangents. And let's go back to Desmos here. And let's go switch cameras. Okay, we're all set. So here we are back in the share screen. So I'm going to plug in y minus 2. That's the first one. Y minus 2 equals negative 9/2 times x minus 1. And look at that. Look at that beautiful tangent. We have a beautiful tangent right there. And now for the other one, we have y plus 2 equals positive 9/2 times x minus 1. Same x minus 1. These are the equations we just figured out. And look at that. We got a perfect thing right there. And lo and behold, with a 1.444 is the x-intercept. I'm not so interested in the x-intercept. But look at that. So we have, let me make this a little bit bigger even. So here we have the two tangent lines. One is tangent at 1, 2. The other one is tangent at 1, negative 2. And the slopes are negatives of each other. They're not negative reciprocals of each other. In case you're wondering, hey, why aren't these two tangent lines perpendicular? Perpendicular has to be negative reciprocal, not just plain negative, but negative reciprocal. Anyway, we see that the diagrams really bear it all out. Okay, let's continue. I want to do another. Let's go back to the. Let's go to this. I want to do another. Let's do another implicit differentiation problem. So I want to do. I want to do. Let me just write it down here. Let's see, x plus xy squared minus y squared equals xy. That's the example. And I just want to find dy dx. Okay, so x plus xy squared minus y squared equals xy. So I want to find dy dx. I'm not plugging anything, I'm just finding dy dx. Now, I'm going to take the derivative of each thing here with respect to x. Now here, the derivative of x is just 1. No derivative. Now, this guy here is actually a product. X is a function of x, and y is a function of x. It's really like an f and a g. We have to do the product now. So it's going to be y squared, because the derivative of x is just 1. I'm going to put the 1 there. The derivative of x is just 1, plus x times 2y times y prime. So this is my, just to label everything, this is my f, that's my g prime, that's my f prime, sorry about that. And that's my g, darn. And that's my f, and that's my g prime, and that's my inner, because y is a function of x. Now minus the derivative of y squared is 2y times the inner derivative, which is y prime. And here we have to do a similar product rule. The f prime is 1 times y plus, again, this is that's my f prime g in the product rule. And this is that's my outer, that's my inner. Just kind of labeling what these are all coming from. So we use product rule, a whole bunch of stuff. Now what I'm going to do is I want to solve for y primes. I want all the y primes on one side and everything else on the other side. So what I'm going to do here, I'm going to subtract them. I'm going to subtract this, subtract that, and subtract that. And I'm going to get, and subtract that. Actually, the y I'm going to leave. So this is going to give me 2 xy prime minus 2y prime. And this guy here I'm going to bring to the other side, so it's minus xy prime. The 1 is going to, the y here is going to stay, but the 1 is going to go to the other side, and the y squared is going to go to the other side. So it's minus y squared and minus 1. I brought the y squared over to the other side. So, and notice anything that has a y prime in it comes on the left side. Anything which does not have the y prime goes on the right side. Now I'm going to factor out the y prime. So I have 2xy minus 2y minus x, all that times y prime equals y minus y squared minus 1. Now we're going to divide both sides by 2xy minus 2y minus x, and divide that by 2xy minus 2y minus x. And that's my final answer. So my final answer is y prime, or dy dx, it doesn't matter what I call it, dy dx equals this fraction, y minus y squared minus 1 over 2xy minus 2y minus x. And that is a thing of beauty. Okay, that was very lovely. And now switching cameras again. I'm going to share my screen. And I'm going to, okay, we're done with that. Let's go to open this. Let's go to our Google Doc. I just want to put this problem in there. Now, I have to warn you, when I first saw that this problem is actually from our textbook. When I first saw it, I really could barely stop laughing because I loved it. But you'll see what I'm talking about. Wow, we did a lot, you know? When you look back, it's a funny thing, you don't realize how much you've done. When you look back, you see, wow, we've really done a lot. Okay, here's the problem. A young woman and her boyfriend plan to elope. She must rescue him from his mother, who has locked him in his room. The young woman has placed a 20-foot long ladder against his house and is knocking on his window when his mother begins pulling the bottom of the ladder away from the house at a rate of 3 feet per second. It's like, I'm sorry, I just can't stop laughing. How fast is the top of the ladder and the young couple falling when the bottom of the ladder is 12 feet from the bottom of the wall? How fast when it's 16 feet? How fast when it's 19 feet? Okay. So let's I find this very hilarious. So let's work this out here. Um, anyway, let's let me just go about a piece of paper here. The ladder is 20 and she's pulling it at 3 feet per second. Okay. So let me so basically what I'm gonna draw this on paper, but what I want to point out is basically the ladder, the wall, the floor, the ground, I don't know, and the ladder form a right triangle. So that's the wall, that's the ground, and that's the ladder forms a right triangle. And we're going to make use of that fact. So let me switch cameras. And okay, so here is the so here's the wall, ground, and the ladder. Now I'm going to call the wall W. W is for a wall. And I'm going to call the ground G. G is for ground. And and the ladder we said is 20. That's fixed, it's 20. And we mentioned that the mama is pulling the ladder at dg dt equals 3, right? That's what we said, right? I believe it's 3 what was it, 3 feet per second. It's 3 feet per second. Okay, the GGT is 3. And I would love to have some. Now, they're asking us again to find the rate that W is. Well, W is obviously going to decrease. I mean, I think it's common sense W is going to decrease. If I pull the ladder out, the W decrease. If I pull the bottom out, then the top falls. So I want to find the rate that W is changing, but I don't know what it is. I only know the rate that G is changing because that's given to us. I know the length of the ladder. It's a 20-foot ladder. But even though I don't know W, they don't give us W. W is related to G because they're in the same triangle. And there is a very famous formula that relates the size of a right triangle, and that's known as the Pythagorean Theorem. And that tells me that W squared plus G squared equals 20 squared. Squared. 20 squared. Now I'm going to take the derivative of everything with respect to t. So the derivative here with respect to t, that's 2w dw dt. And for g squared, I have 2g dg dt. And the derivative of 20 squared, well, that's a constant, so it's just 0. Now, I know that dg dt is equal to 3. So let me write this again. Well, wait a second. I have two things I don't know. I don't know the w dt. That's what I'm trying to find. And I don't know w. So, what is G? I do know G because they're telling us that G, the problem said, well, this is the problem said that G was, oops. The problem told us that G was 12. The bottom told us, the problem, the given, told us that G equaled 12. Well, but what's W? Well, if I want to know what is W when G equals 12, because W changes every time G changes, well, what is W when G equals 12? We're going to use the Pythagorean theorem. In other words, I'm looking specifically at a case but that's 12, and that's 20, and that's W. And if I use Pythagorean theorem, I get W squared equals 400 minus 144, which is 256. So W equals 16. So now I can plug everything in. 2W, that's 2 times 16 times dW dt plus 2 times G, which is 12, times dt dt, which is giving us 3, equals 0. And now I say 2 times 16 times dW dt equals, I should 76 equals negative, what's that, 24 plus 3 is 72, negative 72. And I divide both sides by 32, right? So dW dt equals negative 32 over, which, let's see, that comes to 3618. Oh, look at that. Divide both sides by 8. 9 and 4, negative 9/4 feet per second. Now, am I surprised that I got a negative answer? I'm absolutely not surprised, because as G is increasing, W is decreasing, because when G gets further away from the wall, W goes down. Now, for question B, this was A. For part B, they gave us that G equals, I think it was 16. G was 16. For part B, they give us that G is 16. So all I'm going to do, but that's going to be, once I've done part A, so I know that I have my formula, I have the equation 2W dW dt plus 2G plus 2G dG dt equals 0. I know that G is 16. Using Pythagorean theorem, I get W is equal to 12. So now I just do 2 times 12 times dW dt plus 2 times 16 times 3 equals 0. So dW dt, that's just going to equal, let's see, that's 1632 times 3 is 32 times 3 is 96. 96 divided by 24. And 96 divided by 24, I think it's just exactly 4. Exactly, sorry, negative 96 over 20. Let's see, that goes into, is that right? 96 divided by 24. I just want to check my calculator. I get exactly 4. Possible. 96 divided by 24. How do you like that? It's negative 4 feet per second. Notice that it's faster. Notice that when G is further from the wall, see here G is, in part A, G was only 12. In part B, G is 16. And notice that when G is bigger, W falls faster. And let's see if that trend continues for part C when we have 19. But for part C, and again, I'm just G equals 19. Now, if G equals 19, W is going to be some horrible, if G is equal to 19, W is going to be some horrible radical. So W is going to equal, W is going to equal the square root of 400 minus, what's 19 square root 3? It's 19 squared, 361, 19. Yeah, 361. Look. And square root of 39 is approximately 6.24. Okay, so I'm going to say now the same equation. 2w dw dt plus 2g dg dt equals 0. So 2 times 6.24 times dw dt equals negative 2 times g, which was 19, times dg dt, which is 3. And it's negatives. I just borrowed the other side and all that. Now I'm dividing both sides by 2 times 6.24. The 2's cancel. So I want 19 times 3 divided by. So dw dt is going to equal negative. Let's take a look at 19 times 3. 19 times 3 divided by 6.4. 6, 2, 4. That comes out to, this on a calculator, 9.13. So again, notice that when 19, it's that's like as far as it can go. As the top, because the bottom is going at a constant rate, it's always just 3 feet per second. But as you get closer away, the teaching that it falls faster. So I found it a little interesting. Anyway, this has been a lovely problem, and gotta watch out for those. You know, honor thy mother and all that. You gotta be careful about that. So that's all I could say. Have a lovely day. Stay away from ladders and angry mothers, and I think you'll do just fine. Anyway, that's it. That's it for this video. See you guys next time. Bye.